So here we've got some standard integrals. Some are on your formula sheet, some you've got to memorize. And even if they're on the formula sheet, so you don't have to memorize them, you've got to be able to recognize when they crop up, because cosec x cot x, is a bit of a mouthful. And if you don't realize that it's a standard integral, and therefore go to your formula sheet, you could be going around in circles for a long time trying to simplify this when it doesn't need simplifying. It's fine as it is. It's just a standard integral. So these standard integrals, cos x is sine x plus c, and almost certainly cannot be used for anything else. So for instance, it would be a grave mistake to believe because cos x integrates to be sine x that you could, for example, say, oh well, cos x squared is sine x squared. Absolutely not. This is cos x and that's it. However, with all of these, there is one exception, and it's this, what I would call the first special case. So it's absolutely crucial that you are aware of this to save yourself a great deal of trouble. You can use any standard integral as long as the argument instead of x is in the form ax plus b. In other words, a linear. So, for instance, cos 2x plus 3, because it's a linear argument, that's the only difference. Instead of x, it's a linear. I know I'm laying it on because I want you to be clear. Couldn't be x squared, couldn't be x cubed. It's a linear. Then I can carry on and use the standard integral. And so I'll get sine 2x plus 3 plus c. But the price you pay is you then have to divide your result by a. In other words, the x coefficient. So think of that as the price you pay for using this special case. That's it. And so it saves a great deal of messing around when you see this crop up, and you will see it crop up. Might not always be very obvious when it crops up, and in particular, if I ask you to integrate this, what you've got to recognize is this standard integral, but instead of x, we've got the linear. And therefore, we can invoke that special case, this rule, because it's this in the form ax plus b. So it's going to be natural log 2x plus 5. I can carry on as normal. But again, because I've used that special rule, I've got to pay the price, divide the answer by a, the x coefficient, which is in this case 2. So we get a half natural log 2x plus 5 plus c. Crucial that you spot that. So let's have a look at one more example. First of all, because this is an integral being multiplied by a constant, which is 15, you should be comfortable with rewriting this as 15 as this. When the whole thing expression is being multiplied by a constant multiple, which is in this case 15, we can take that outside of the integration. We'll carry out the integration as normal and then just multiply the result by 15. So I recognize that this is the standard integral 1 over x. The only difference is the argument, instead of being x, is a linear, ax plus b. So I can carry on as normal. It would be natural log 3x plus 2 plus c. And because I've used that rule, I have to pay the price, divide the result by 3. And that's my answer. And of course, I'm going to times all of this by 15. We can tidy this up. 15 divided by 3 is 5. And so we end up with 5 natural log 3x plus 2, and then plus the c. So whenever you come across integration, be on the lookout for this situation, and fully conversant, with this rule.